Hi everyone, this is lesson D4, and in this lesson we're going to introduce product and quotient rules for finding a derivative. So first we want to talk about the product rule, which says that if you have two functions f and g and they're multiplied together, when you take the derivative you want to do fg prime plus gf prime right here. If you have a product fg and you're doing the derivative, then the derivative of that product is the first times the derivative of the second plus the second times the derivative of the first, fg prime plus gf prime. These things are just saying that same equation using the Leibniz notation. So when you see a function, make sure that you start analyzing what the structure of the function is. If you draw a line through this function right through the middle, you can see, let me use a different pen. If you draw this line through the middle, you can see that there's one function to the left and another function to the right. So those are what I'm calling the first and the second functions. And so if you initially want to write them out on the side and organize their derivatives off to the side, that's probably going to help you find your answer correctly initially. And then when you get better at it, you can stop doing that. But the first function here is x. Its derivative, or the first prime, is 1. The second function is e to the x. Second prime is e to the x, right? So then the derivative of the product is going to be the first times the derivative of the second plus the second times the derivative of the first. And you can write it out like that as you think about it. Say that in your mind first. So first times the derivative of the second plus the second times the derivative of the first. And then you can clean up the equation and kind of drop all the dots in between, just write x e to the x, drop the 1 and write e to the x. You can also pull out an e to the x and write it as e to the x plus times x plus 1. Okay, example 2, s of t is equal to 2t squared minus 5t times e to the t. So make sure it's a product. Here's my first function. Here's my second function. Let me write that as a word. Here's my second. Okay, so my first is 2t squared minus 5t. The first prime is, by the power rule, 4t minus 5. The second is e to the t. The second prime is e to the t, because the exponential function is its own derivative. So then s prime of t is equal to first times the derivative of the second plus the second times the derivative of the first. And you can simplify it. I'm going to go ahead and do that here just to show you some algebra, example. But sometimes you will just leave it pretty unsimplified. You are simplifying only as much as you need to. You either need to simplify to match up to the book answer key, or you're simplifying because you need to do parts B, C, D of the problem and you want to have a simple equation, but you just simplify as much as you need to. So here we have 2t squared e to the t, and then right here, these two terms can be simplified into negative t e to the t minus 5e to the t. If you want to pull this out into e to the t times 2t squared minus t minus 5, you can do that. Okay, the next one is f of x is equal to rad x times g of x, where g of 4 is equal to 2 and g prime of 4 is equal to 3. Find f prime of 4. So we can see that f is a product. If we're finding f prime of 4, we're going to need f prime of x. We don't know what the g function is, right? But don't let that stop you. Always think about what can I do, even if you don't know how exactly to get to the answer. Take the first step and see where it leads you. The first step that's kind of waiting to be done is using the product rule, right? So I can say my first function is rad x. Its derivative, we've done this a few times, x to the 1/2, right, becomes 1/2 x to the minus 1/2, which is 1 over 2 rad x. So this is a good one to memorize. The derivative of rad x is 1 over 2 rad x. The second, we only know that it's called g, and in cases like this, just think in your mind, well, if the function is g, its derivative must be g prime. So then I have first times the derivative of the second plus the second times the derivative of the first. And now look at what we've been given and see what we can do with that. We've been given that g of 4 is 2 and g prime of 4 is 3. So if I say f prime of 4, which is what I'm trying to find, then f prime of 4 is what I'm trying to find. I can just put the numbers in and go, okay, looks like I have everything I need. Rad 4 times 3 plus 2 times 1 over 2 rad 2. I'm sorry, rad 4 because it's rad x. So if x is 4, then I need rad 4. So basically, I think I'm getting 2 times 3, because rad 4 is 2, plus 1 over 2, 6 plus a half, 6 and a half, or 13 and a half. Okay, so moral of that story is, when you look at a problem that seems unfamiliar, just take the first step, do what you can do, and keep on taking steps. And before you know it, you will have the answer. Okay, so this is our product rule. What about our quotient rule? Our quotient rule says that if you have two functions, f and g, and you have f divided by g, and you're taking the derivative, remember we said we do not want to do this. We do not want to do f prime divided by g prime. That does not work, right? What works is the quotient rule. And when we apply the quotient rule, it is useful to call the function that's underneath low. So I'm calling g low, and I'm going to call f high because they are at the bottom and the top of the fraction. And then there's a little ditty, chant, poem, whatever you want to call it, that goes low d high minus high d low over low squared or low low. If you're too cool for that and you want to say gf prime minus fg prime over g squared, that's fine too, right? So the point is you have to remember how to do the quotient rule. So here we have, this is my function, and I can call this low and this high, and then I can go off to the side, and initially I would do this so that you don't make mistakes. So if low is x cubed plus 6, d low is 3x squared. If high is x squared plus x minus 2, then d high is 2x plus 1, right? And I'm applying the power rule. Okay, so then f prime is low d high, make sure you put parentheses whenever you have more than one term, minus high d low. And for this, I want you to put big parentheses here around that whole subtracted term. So low d high, this is low d high minus high d low, okay? And then it's going to be over low squared, which is x cubed plus 6, the quantity squared. Please remember that x cubed plus 6, the quantity squared, is not equal to x to the 6 plus 36. That is incorrect. So we're going to just leave it like that for now. Okay, I'm going to simplify the top just to show you how that algebra would work. We're going to FOIL out every term there. So 2x to the 4th plus x cubed plus 12x plus 6 minus, and just leave the brackets here. First, we're going to do the distribute, 3x to the 4th plus 3x cubed minus 6x squared. And it's all over x cubed plus 6, the quantity squared. Okay, so now the top, you have to distribute that negative sign. It's a very common mistake to not properly distribute this negative sign. When you distribute it, we're going to get this, okay? And now you're going to combine like terms on the top, and you are going to end up with, let's see, 2x to the 4th. And then x cubed here minus 3x cubed there, that makes minus 2x cubed. 12x, I forgot x to the 4th term. I should have said 2x to the 4th minus 3x to the 4th. That makes just negative x to the 4th. Oh, wrong color. Negative x to the 4th. Okay, then minus 2x cubed. And then let's see, plus 6x squared plus 12x, and the last is plus 6, and it's all over x cubed plus 6, the quantity squared. Okay, so that's a simplify. Again, you only simplify as much as the problem indicates that you have to. So sometimes we'll even just leave our answer like this up here. Okay, next question. Find the equation of the tangent line to this graph. F of x equals e to the x 1 over 1 plus x squared at this point, 1e over 2. Okay, so for a tangent line, we always need a point. We've been given the point, and we need the slope. The slope is going to be the derivative at this x value, right? So I need a quotient rule. Low d high, this is a quotient, right? So to differentiate it, I need a quotient rule. Low d high minus high d low over low squared. And now do it all at 1. I would just put the 1 in. I wouldn't go around simplifying that because all I'm after is this one number. And so I'll just get that as quickly as I can. 2 times 1 and then 1 plus 1 squared. So I'm going to get 2e minus 2 times 1 is 2 times e is e. 2e minus 2e over 4. But 2e minus 2e is 0. So 0 over 4 is 0. So I'm talking about a horizontal line, right, that goes through this point 1 comma e over 2. Horizontal lines always look like y is equal something. If I have to go through this y, then it must be y is equal to e over 2. If you wanted, you could just do y minus y1 is equal to m times x. I'm sorry, y minus y1, this is y1, this is x1. Y minus y1 is equal to m times x minus x1. But because of the m being 0, all of this side is 0, and you're going to end up with y is equal to e over 2. That is our tangent line. If you needed a normal line for that, it would be equal to x is equal to 1, right? Any line y is equal to something, the perpendicular to that is going to be x is equal to something. And if you need to go through the point 1, then this would have to be the normal line. Okay, the next one. Find the equations of the tangent and the normal line to the function at the specified point, right? So here we have the point. And by the way, recognize that if they didn't give you the y value, right, the 1/2, then you would just do f of 0 because the point is 0 comma f of 0. And f of 0 would work out to be 1/2. Okay. So we've got our point, we need our slope. F prime of 0 is our slope. And so we just have to do low d high minus high d low over low squared. Again, do not distribute the 2 on that bottom. It's not 1 plus e to the 2x. So hang on, low d high. I think that's right. Okay. So now we need f prime of 0, so you can just go 1 plus e to the 0 times 1 minus 1 plus 0 times e to the 0 over 1 plus e to the 0 squared. E to the 0 is 1, so this becomes 2 minus 1 over, this is 2, 2 squared is 4. So I get 1/4 for my slope. And so then the slope is equal to 1/4. My tangent line is y minus 1/2 is equal to 1/4 times x minus 0. And my normal line is y minus, let's do that in red, y minus 1/2 is equal to -4 times x minus 0. Okay, so that's the quotient rule. Okay, the last two problems are applying the quotient rule to tables and graphs. So this first question 7 here says the differentiable functions f and g are defined for all real numbers x. Values of f, f prime, g, and g prime are given in the table. So tables, make sure you know how to read them. These are your x values, and then you're given like f of x, f prime of x. Please don't make any assumptions about anything else with these functions, right? All you know is these x values and their function and derivative values. We do know, by the way, that the function is differentiable, and that means that it is also, these functions are both continuous. Okay, so let's do the second one first. When it says d dx of f of x, g of x at x is equal to 3, you can see it's a product. And when you're just given that kind of problem, you can just write the product rule at x is equal to 3. So you can say this is equal to f of 3, g prime of 3. Really, I should put it this way. This whole thing, the derivative of the product at x is equal to 3. That's what is equal to f of 3, g prime of 3 plus g of 3, f prime of 3, right? So it's the product rule written at the point 3. Then you go into the table and, say 3 is our green row here, right? You just want to carefully find the numbers. F of 3, g prime of 3, so it's times -4 plus g of 3, f prime of 3, which is 8. So we get -4 minus 32 or -36 as our answer, okay? Something like C can be done the exact same way, except we're using the quotient rule. So this guy will be low, so I'm going to do it all at 2. Low d high minus high, high is f, high d low over low squared. And then we want to go to the row which is 2. So I'm talking about 2's, right? So I might find the row which is 2, be in the right row, and then you say this is equal to g of 2, which is 16, times f prime of 2, which is -5, minus f of 2, which is 3, times g prime of 2, which is 1, and it's all over g of 2, which is 16 squared. So this works out to be -83 over 256. Weird number, but that's the right answer. Okay, and then back to A. So A takes the function in the table f, but then it's multiplying it by rad x, and you're asked to find the derivative at 4. For this type of problem where it's not just straight f and g out of the table, I like better to write the equation for this product first in terms of an equation, and then I put in x is equal to 4. So I go rad x, the first, right? Here's the first function and the second function. First times the derivative of the second plus the second times the derivative of rad x, which is 1 over 2 rad x. And then I say d dx of this thing at 4, right? And by the way, a notation for that is this long line and x is equal to 4. That means the derivative at x is equal to 4. And now I'm going to put 4 in for each of these x's. I'm going to put 4 in, and I'll be in this row then to get my numbers. And so I'm going to go rad 4 times f prime of 4, which is -1, plus f of 4, which is 16 over 1 over 2 rad 4. So I'm going to get -2 plus 4, which is +2, right? So my answer to that problem is +2. Okay, last problem is exact same thing, product and quotient rules from a graph, right? So I've been given two functions, big F and big G, and they're shown in the graph. And then I'm finding P of x is f times g and q of x is f over g, and we're starting with p prime of 2. That's going to be my first part A. Let me write it here. P prime of 2. Okay, so P prime of 2 is going to be f of 2 g prime of 2 plus g of 2 f prime of 2. Okay, so now we just have to go to the graph and read it carefully. We're at x is equal to 2. F is this graph on top. F of 2 means the y value there. So that is equal to 3, right? 2 comma 3. That means f of 2 is equal to 3. And then f prime of 2 is going to be the slope of the tangent line there, which looks like 0, right? It's clearly a horizontal tangent line there. G of 2, well, now we're on the lower graph, on this G graph, and we're still at x is equal to 2. G of 2 is right here, 2 comma 2. And G prime of 2, well, it's a straight line, so that's just going to be the slope of that line, which is 1 up for 2 over. the slope of this line is 1/2, right? So g prime of 2 is 1/2 and g of 2 is 2. So we need to just make sure we get all that right. And then it's a matter of just putting it into the equation. 3 times 1/2 plus 2 times 0 is 3/2, not 3.5, right? 3 times 1/2, numerator times numerator, denominator times denominator. That's 3/2. Okay, last problem, q prime of 7. We'll do it out here. Q prime of 7, Q is a quotient. It's F over G, I think. Double check that. F over G, yeah. So it's low D high minus high D low over low squared. Okay, so we're going to go to 7. 7 is out here. And let me look at this. So we're on the graph of f, we're at 7 comma 5, and the slope of that line is 1/4. And then for the g graph, we're down here at 7 comma 1, and the slope of this line is negative 2/3, right? 2 up for 3 over. So you want to go to a place on the line where you can very clearly see what the graph slope would be. Okay, so now we have g of 7 times f prime of 7 minus f of 7 times g prime of 7, which is negative 2/3 all over 1 squared. So I get 1/4 plus 10/3. And if I make a common denominator of 12, then I get 43 over 12 as my final answer. Okay, so your takeaways are the product and quotient rule, and then knowing how to apply it to do a host of things, including writing tangent line equations, normal line equations, as well as learning how to do the product and quotient rule from graphs and tables. That's about it. Have a great rest of your day.